All right, thank you so much for coming, even though it's after lunch. I know I'm tired as well, but let's just get through this together, and then we will, we will all be smarter and happier and fulfilled. So yeah, I'm going to be talking about secret management today, the soft way. Why the soft way? Because everything's the hard way always. I don't know. It's like this hardcore engineering that I'm hearing so much about. But I think one of the great things about this community is that we help each other out, right? So why not do things kind of in a softer approach, like not easy but straightforward, right? So I hope that with my talk today, I'll show you some ways to do secret management, but without getting frustrated. So first up, a little bit about myself. My name is Lian Li. I'm a developer advocate with Loft Labs. We do tooling on Kubernetes. It has basically nothing to do with my talk, because I did have this talk before I joined the company. But I'm going to hand out stickers to the company later, so yeah, just hit me up. And you can find me on the internet. You can find me, as long as it still exists, on the Bird app at Lian Makes Things. That is my handle all over the internet. So if you go to any kind of social media, you probably will find me at Lian Makes Things. And also you can send me an email if you still do that. It's lian@loft.sh. You can also try me on LinkedIn, but you just have to wait for a reply for like half a year or something. In my former life, I used to be a cloud-native consultant, actually with Container Solutions, who are here also today. And I have a background in software developers. I used to be a web developer. I moved to DevOps, and then to, like Kubernetes. I heard DevOps is dead, so I don't think we can still say that. All right, someone's just like, oh no, she's not talking about that. No, I'm not talking about that. Anyhow, I just wanted to give you some background, where my knowledge comes from, and a lot of what I'm showing you today is some stuff that I worked on with clients. So let's jump into the topic. So on Kubernetes, everyone knows the secret. And it's not necessarily that, it's not that simple, but basically, if someone has access to your Kubernetes cluster and they have the necessary permissions, they will be able to read the secrets on your cluster. The reason why is because of the secret resource, and that's what it looks like. So it's a secret. This is not okay. So you have a okay. Let's just try to get through this together. You have a secret type, and you have this data field here, and you can put in like keys and then the values. And these values, they're not encrypted. They're base64 encoded. So I could just copy, paste this, run it through like a base64 decoder, and then I'll be able to read the username and password here. This is not a bug. That's how it's supposed to work. This is just like the way that Kubernetes secrets are supposed to work. In the olden times, you often had like credentials somewhere in plain text, like on someone's laptop or whatever. And the way that you would, make sure that these credentials don't get into the wrong hands is just by not giving the devs access to the cluster, right? They could see the code, they know that they can reference these credentials, but they won't be able to see it because they don't have access to the actual production environment. So now, with the advent of GitOps, and I'm just like, does anyone not, okay, maybe that's not good. Does anyone know what GitOps is and what it does and how it works? Okay, some, but not all, right. So in GitOps, the idea is that you will put your, all of your manifests, everything that describes the environment that you're deploying to, you put it in a Git repository. This has a couple of advantages and disadvantages. So you can, as I said, deliver all your resources in one place, which can be good because then you just need to look at this one place and you understand this is the desired state of my environment as of this time. You have built-in access control. So you can use the access control that Git or like GitHub, the Git providers give you. I don't know, Bitbucket, GitLab, everything that's out there. And you don't have to like necessarily build that yourself, which is pretty good. And you also have a persistent history of the states of your environment. So for example, if you have one Git repository for each environment, you can look at the history and then you'll know, oh, at this time, like Clive tried to deploy this change to production. This comes with a caveat because Git is not 100% tamper-proof. Like you can always somehow change the tree. It's always possible. So if someone messes with it, it's not really 100% safe. There are ways that you can mitigate it. You can protect like your main branch and only allow changes through pull requests, and then you can protect the pull requests so to only allow some people to approve them. So there's ways that you can try and keep bad actors out of that. Then on the other hand, though, your developers, usually they will have some kind of write access to the Git repo because you want them to put the desired changes into the Git repo. Maybe directly, maybe they have direct access, or maybe they use some kind of delivery process to do that. So they might have some kind of access to the Git repository, which means they possibly have read access to the Git repository, which means they can now read the secrets again, because you put the secrets in there, and as we saw before, they are not encrypted, but only encoded. So we went from, like, devs did not have access to prod all the way to, okay, maybe they do have access to prod, but like indirectly through this GitOps abstraction. So I'm gonna take a step back just to, add a thought to this, which is the idea of desire paths. I'm sure you probably have seen that, you just don't know what it's called. So a desire path is like it's a pathway that's created by the erosion of humans or animals who like walk through it. And it's kind of a sign of like what is the ideal path that humans and animals are taking, because they're either lazy or very smart. And the thing about desire paths is that sometimes you have a situation like this, where there is something that's built, there's a path that's built, but it's either so terribly maintained, like this one, or it's just so inconvenient, like that one, that people will just take an alternative route, right? And the problem with that is that, especially if you can see here, this will actually weaken the overall structure of your system, because people will take the path of least resistance, which is maybe not the path that you designed. And by doing that, they will introduce new security vulnerabilities, maybe, like someone will leave, we'll just put like a VPN open or whatever, SSH entry point open. And so like the thing that you built is working fine, but no one's using it, and actually, like leaving your system open to exploitation. So when you build something, when you do stuff, especially when it comes to security, you always have to keep in mind, like, how do my users actually want to use the system? Because if it's like, oh, I have to like open 5 Jira tickets or whatever to kind of get my secret onto the cluster, then I can almost guarantee you that people will not be doing that. They will find some way that they can find some workaround for that. So I'm going to show you an example or 2 examples of what you could do, how you could manage your secrets. And I've just thought of like a use case to kind of like make it easier to follow and understand. So when we are building a system and we want to keep in mind kind of the desire path of our users, this is a list of objectives I've come up with, and it's totally feasible that it's different for you and your organization. Like this is just what I've come up with, for myself, from the experience that I have. So number 1, and these are numbered because they're by priority, I want to consume secrets consistently across environments, which means that I don't want to have different code delivered to different environments. And ideally, I also don't want stuff in my code that says, oh, if I'm on production, then I'm going to read it from here. And if I'm on dev or staging, I'm going to read it from there. Ideally, your code just shouldn't even know where it's living. It just should work always the same way. Second, I want to keep the secrets, especially the production secrets, out of the hand of my developers. Not because I don't trust them. I mean, I probably don't. But also because people make mistakes. People are maybe, I don't know, desperate. I don't know. And things happen. Like I doubt that unless you are shilling crypto, you're maliciously trying to hurt your consumers, right? But things happen. So if there's some exploit or something happening, you want to keep the burst radius as small as possible. Also, I want developers to have a good experience with working with secrets. Like this is the whole like desire path thing. Again, if I have to open like 4 Jira tickets and have to wait on like 3 teams just to get some secrets into the cluster, people won't be doing that. They will find other ways to get the credentials into their code, and it's not going to be pretty. And then finally, I want to use open source tooling. I think open source is a great concept, great idea. It works. I think it works amazing. But also, if you're able to see the inner workings of the tool that you're using, for one thing, I believe it will add to the trust of this tool and of your system, because you know where the vulnerabilities are, the possible vulnerabilities, and you can mitigate that in other places of your system. So yeah, I think using open source tools is always a big plus if you can do that. All right, so this is kind of the checklist of goals that I have, and then the setup for my experiment will be looking like this. So I want this secret to live on my cluster eventually. It's just called test secret. It has 2 key value pairs. One is the environment, so it will say dev or prod, and then the source, in this case, will say YAML, because this is from a YAML originally. And then this is the pod that I'm deploying to read this secret, and let me see if this works now. Okay, great. So yeah, I have this, it's a busy box, and I'm mounting the secret into the environment, and then I'm gonna echo the values here. Now, I hope it goes without saying, but don't actually echo your secrets into your container, right? Like this is just for the showcasing purposes. I just wanna make sure that I'm just saying it just in case. All right. So generally, well, in this example that I'm showing you, we have 2 options. Number 1 is that we encrypt our secrets before we deliver them. So we will take our secrets, we will encrypt them, and then we will put them in the Git repository. And to do that, I'm using a tool called Sealed Secrets. There's also another tool called SOPs. It is kind of like the similar idea. So you encrypt them, and then you put them into the Git repository. And you can also, the other option is to deliver a reference to those secrets. So you don't keep the secrets actually in the Git repository. You keep a reference there, and your secrets are actually somewhere else. So one way that you could do that is you keep your secrets in HashiCorp Vault, which is a great open source tool, and then you use the external secrets operator to now grab those secrets from Vault and then deliver it onto your cluster. Okay, let me just have a quick drink, and then actually good for time. So the first option is we're using the Bitnami sealed secrets, and this is the general architecture of how it works. So we have our Kubernetes cluster, we have the ops repository, and we have the developer's machine. And on the cluster, we have the sealed secrets operator. Now, if you don't know what an operator is, very quickly, it is some kind of controller that will manage the state of specific resources on Kubernetes, mostly custom resources that you install yourself. And then as soon as the state of one of those resources changes, the operator will be doing something. So in this case, we install the operator, and the first thing we do is we generate a key pair. And we use this key pair to end and decrypt our secrets. Later more. So one of the first things that we do is that we have, as a developer, we ask the operator to give us the public key, and we can save the public key on the machine. And it's totally okay because the public key is okay to share. And we can use the public key now to seal our secret. So we start with a Kubernetes secret, a regular secret, and we use the pub key to seal it. And that sealed secret will look like this. It is very similar to a regular Kubernetes secret, except that we now have this field in the spec. It's called encrypted data. The keys are not encrypted, like the key names are not encrypted, but this is encrypted now. And we can also say that to decrypt, we wanted to have a specific template, so we could rename the secret here if we wanted to, and we could change the type if we wanted to. So once we've sealed our secret, the next thing is we put the secret into the ops repository, we deliver it with all our other resources, and then whatever mechanism deploys stuff will take the sealed secret and deploy it with all the other stuff into our cluster. Now the sealed secrets operator is, as I said, monitoring the status of sealed secrets in this case. And as soon as it detects a change, it will now take the private key and decrypt the sealed secret and then create a Kubernetes secret, which ideally should be the secret we had at the beginning, and deploy that to the cluster. Okay, so, oops. As I said before, I'm attempting a live demo, so I'm already, and I'm only doing that so I can cheekily show you some of our tools that I said before have nothing to do with what I do, but at the same time, I'm on stage, so why not show you some tools? So what I have here is, like, one of the projects that we have are virtual clusters. They're like lightweight, tiny Kubernetes clusters on top of a regular cluster, which allows me to do stuff like, I run Docker Desktop here. I run the Docker Desktop Kubernetes cluster, and I can have my experimental virtual clusters, and then if I don't need them, I can pause them, and they don't hog any resources, which is super cool. So now I'm connected to the sealed secrets cluster, and if we look at what's in there, so as you can see, there's already the sealed secrets controller installed. But other than that, I just have my regular, my regular namespaces that I have from the beginning. So what I'm doing right now, as I showed you before, the first thing I need to do is I have to actually fetch the public key, which I do with this kubectl command. I don't know if you can read what's down there. And so I have now the public key on my machine. And then the next thing I'm going to do is I'm going to, can you read this down there, by the way? Otherwise, I will try to give me a...
If you clear and run the command again.
Okay, yeah, fair. So, okay, so now I've sealed the original secret that I had, and we can, like, if we're interested in that, we can just take a look at this. This is exactly what I showed you before. And the sealed secret will look like this. So, yeah, as I said, so we will just have this encrypted data here, and the rest is exactly what I showed you before. So now I will create a namespace. Okay, just believe me that I created a namespace. I will now apply the sealed secret. All right, and then I need to find my cursor. And then I will, so actually we could probably already see the secret. So yeah, we have the secret already here. We could also already look at it. Scribe secret. Oh, yeah, okay, that's happened. That's the scribe. I definitely wanted to do a does that work? Yeah, okay. So what you can see here, and I just wanted to show you the owner reference here, so we can all agree that I didn't create that secret, but the sealed secret operator did that for me. So now to my final trick. If I now deploy this pod, then I should be able to, oh, wait. Okay, so I should be able to see the logs, probably. Oh no, because I didn't put logs. I should have really prepared better for the demo. Okay. And then one thing I forgot to mention when I showed you the pod earlier is that because we're just, yes, I do mean logs. Because we are loading the secret into the environment, oh, come on. Oh, is it because I'm putting the OYAML at the beginning? Probably. So what I wanted to say is because we're just mounting the secret into the container, I don't have to specify that I'm on prod and sorry about that. I'm almost there. See, this is live. This is how we know it's live. I don't need the, oh my God, I'm doing logs. Okay, all right. Okay, you know what? I'm giving up now.
Namespace, maybe?
Oh, because it's not called pods reading secret, it's just called reading secret. That was the name of the YAML. Okay. Yes. All right. Woo. This is just one of the demos. All right. You are way too easy to. Okay. All right. So what I wanted to say was that because of the pod mounting things into the environment, you don't have to specify that the secret is called prod secret or whatever. It's just the secret that you deploy to the cluster. So you deploy the prod secret to the prod cluster and the dev secret into the dev cluster, or the staging secret into the staging cluster. And the pod itself just uses the secret that's called test secret, and it doesn't know whether it's prod or dev. And that's what I mean by consuming your secrets consistently across environments. All right, that cost me a lot of time. All right, so quickly. In summary, if you're using sealed secrets, what you have to do is you need to manage your secrets somewhere separately, because you have to just put it into the Git repository, but it's not being managed there, so someone else has to manage it. You can deliver now your secrets with the rest of the GitOps repository, which is pretty great because everything that's on your cluster lives in the repository. Some people don't think it's great, but I think it's pretty good. The pub key. You can share that. So you don't need access to the cluster technically. Someone can just grab the key and then give it to you, and you can share the pub key among all the engineers, and that's totally fine and safe. The only downside to it is that because the private public key pair are regenerated every time you install the operator onto the cluster, if you have multiple clusters with multiple different instances of the operator, you have to reseal your secret every time for each specific environment. There is technically a way, I'm just telling you for completeness, not that you shouldn't be doing this. There's technically a way that you can rotate the private public key pairs. So you could use the same key pair for all your clusters, but then you're removing the private key from the cluster and the whole thing kind of becomes moot. So you shouldn't be doing that, but it's technically possible. Okay, so I have about 10 minutes, is that right? Okay. All right, so the second way to do things is, as I said, with HashiCorp Vault and the external secrets operator, which allows you to reference the secret but store it somewhere else. So the architecture is kind of similar in that you have all the same components, but also you have HashiCorp Vault, and it can live in a lot of places, but it doesn't have to live on a cluster, but it could. So you start with adding an entry to Vault, and in the example I'm going to show you, it's a key value entry. And on the Kubernetes cluster, you have an operator. This time it's an external secrets operator. And the operator is tied to a service account. And that service account you have to tie to a role and policy in Vault. So you basically say that there's a role that can read this entry, and the service account on the Kubernetes cluster is allowed to assume that role. And then you have to create a secret store, and in that secret store, you basically define which role to associate with a service account. So the way that the secret store works, it's pretty straightforward. I don't know if it's implemented pretty straightforwardly, but if you want to use it, it's pretty simple. So basically what you have to say is that, and this is on the cluster, right? You say that this is a secret store, it's a cluster scope, and I'm using Vault to get my secrets from. This is where it lives. This is where you can find the entries. And then here I'm specifying that I'm using the Kubernetes authentication method, and you can find that mounted under Kubernetes in Vault, and you can use this role. So this role is something that I had to create myself. So now we've got the secret store and the service account set up, and we can now create an external secret on our dev machine, and that is the reference to our entry over there. So the way that this looks is, again, pretty straightforward. First, you have to define which secret store you want to use. So I'm using the Vault backend. And this is pretty cool because if I decide to not use Vault one day and go to GCP or whatever, I can keep the rest of this. All I need to do is I just have to replace this secret store ref with the GCP backend that I'm going to create, and the rest stays the same. So that's pretty cool. And then again, I have this data property, and here I'm basically mapping the entry in Vault to what I want the secret to be that the external secrets operator should create for me. So yeah, I could like change the names here and whatever, or I can like, yeah, if I have like different instances of it, I could like play around with it a little bit here. So same thing, once I have my external secrets on my dev machine, I put it onto the GitOps repository, and whatever system will deploy it to me, puts it on the cluster, and then the secrets operator will realize, oh, there's an external secret, a new one, so it will go check the service account and the secret store to find the right role and policy, to read the entry, and that will be fed back into the operator, which will then deploy a secret. Just realized, I forgot to tell you that the reason why some are dotted and some are dashed and some are like full lines is because I tried to illustrate that all of this, all the dash stuff, that's the developer's responsibility. The regular lines are the ops team's responsibility, and then the dotted lines technically could be a security team if you have that. Demo. I highly doubt we have time for a demo, so I'm not going to do that. I'm just going to risk it. If you are interested, I put the slides up, and you can like I've also recorded demos, so you can check the recorded demo, and it will work 100%. All right. So, in summary, the cool thing about the external secrets operator, and I know that's going to be a talk about it tomorrow. So if you want to learn more about that, I highly recommend. I think Ben from Container Solutions is giving that talk tomorrow. It's the last slot, so don't go away. But it works with many cloud providers. So I showed it to you with Vault, and that Vault was living on my own cluster. But you could also use the GCP and AWS and Azure identity providers if you wanted to, and like a bunch of others. And as I said, it's easy to or it's straightforward to switch them out if you want to. The dev teams can now safely manage their secrets through Vault, which is like a big advantage because now you have an actual system to manage your secrets in, which comes with all the best practices, rotating your keys and everything, which again is super important for you to do, and it's you have it built in if you're using Vault. The downside to it is that the setup is a bit more elaborate, as you saw. You have to connect the Vault with the Kubernetes instance, which can be a tiny bit tedious. So if you're a two-person shop, maybe just trying stuff out, unless it's really security related, I would probably recommend for you to try something like sealed secrets first, and then once you want to scale up, because you don't want to reseal 100 secrets by hand, but you probably also don't want to set up all this universe of Vault and everything if you're just managing secrets for two people. So yeah, use the right tool for the right problem. So you can find the GitHub repository with all the examples, and you can try it out for yourself. There's a README and everything. If you follow that QR code, I promise there's nothing evil behind it. And so yeah, just to summarize very quickly, what we did do is we managed secrets, and we did something with them, and then we put them in the GitOps repository, and then we had some operators that would then make Kubernetes secrets out of them. So we kind of made the supply chain a bit more secure. But the Kubernetes secrets at the end of the day, they're still unencrypted because they're Kubernetes secrets. That's just the way that it works. So you have to keep that in mind. There are ways to just completely get rid of Kubernetes secrets. You can use the Vault injection. You can use, you can just call out to wherever you need to call out to from your pod. So yeah, you need to keep that in mind. Also, you need to secure your cluster, right? That goes without saying. That's out of scope for this thing, but you need to secure your cluster anyway. Oh yeah, there's the point. So so the thing about Kubernetes is that it does, with the exception of maybe pods, Kubernetes doesn't really understand its resources. It just knows that there's a resource that's called secrets, and I'm doing stuff with it, but it doesn't understand that kind of like, oh, this is a secret, so I need to like encrypt it and do all these things. It's kind of like this manager who says, I've decided we need an SQL database, and then I need you to tell me what an SQL database is. So Kubernetes is managing secrets, but it doesn't understand them really. And to go back to the idea of the desire paths, like this is taken from Reddit, by the way. Like if you listen to your developers, and you know that they like to use secrets in this particular way, what you can do is you can build on top of that and ask them to help you and test stuff for you, to make it more robust and to make it more useful, just like here. Instead of trying to like build something that like is super well designed and uses all the nice technologies, but then no one actually wants to use it because it's not great or it's not useful for them particularly. So I finished, I think, 1 minute before. So if you have any questions, maybe ask me outside. I have a bunch of stickers, as I said, and maybe I'll show you the demo that I didn't have time to show. Thank you so much.